Hi there! Welcome to the ALLS YouTube channel. This season's final episode features Mr. Kiel Lagmay, a Learning Management Systems Analysis Research Assistant of the Ateneo Laboratory for Learning Sciences. From October to November 2020, the Philippines was struck by 8 typhoons, 2 of which caused widespread flooding, utilities interruptions, property destruction, and loss of life. How did these severe weather conditions affect online learning participation of undergraduate and graduate students in the midst of the COVID-19 pandemic? In his talk entitled Quantifying the Impact of Severe Weather Conditions on Online Learning During the COVID-19 Pandemic, Mr. Lagmay discusses findings on the impact of typhoons on student online participation. Eager to learn more? Please continue watching.
Good afternoon once again. I am Kiel Lagmay and I'm currently working with Ma'am Didit for the analysis of learning management systems, specifically Moodle and Canvas here at Ateneo Laboratory for the Learning Sciences. Thank you very much, Ma'am Didit, for this wonderful introduction a while ago. And today, I will be discussing quantifying the impact of severe weather conditions on online learning during the COVID-19 pandemic. This is based from the short paper I have presented during the AIED 2021, but I've decided to add in some additional info and results from the RPTEL draft, which Ma'am Didit and I are still revising. With that said, let me give you a short background of the study. The students' achievement levels in math, science, and English in the Philippines were among the poorest, if not the poorest, among countries in at least 3 international achievement tests, including the TIMSS and PISA. Then, during the COVID-19 pandemic, students and teachers had to transition from a face-to-face mode of instruction to online learning. This was a tremendous challenge to an educational system that was already in crisis. And then, teachers and students struggled to transition to online learning worsened when typhoons Goni or Wally and Vamco or Ulysses caused widespread property destruction, utilities disruptions, and loss of life. We are interested in the impact that these typhoons had on teaching and learning online. Our research questions are, number 1, to what extent were students affected by these severe weather events? And were they able to return to normal levels of online participation, or did these calamities dampen the performance for the rest of the post-typhoon period? For the methodology, we decided to analyze Moodle log files collected from a university in Metro Manila, Philippines from September 9, 2020 to January 9, 2021. This comprises of the first quarter from September 9 to October 24 and second quarter from October 28 to January 29 from the academic year 2020 to 2021. And we have analyzed a total of 2,641,461 logs from 12,699 users. This includes 11,736 students, 925 teachers, and 38 non-editing teachers or teaching assistants. Undergraduate students were from 18 to 22 years old, while graduate students were 23 and older, generally coming from middle to upper class families. On the other hand, teachers had at least a bachelor's degree in the subject area that they were teaching. Most had master's degree or higher. Both students and teachers were a mix of males and female. Although, when you take a look at the Moodle log data, there's no way to directly determine the actual percentage or distribution of the genders. And speaking of Moodle log file, each Moodle log file contains the following contents, such as time, which is the timestamp of the action up to the minute, user ID, which is the numerical identifier or the ID of the user performing the action. We also have the affected user, which is the numerical identifier of the user affected by the action. For instance, when teacher T sends a notification to student S, the user ID will be that of teacher T, whereas the affected user will be student S. Next, we have event context, which is the teacher-given name of the module or activity within which the action took place, like Classroom Exercise 1, Module 1. And we have the component, which is one of 43 Moodle-defined category under which various events take place, like quiz. And we also have the event name, which is one of 244 Moodle-defined names for actions that can be performed by the user, like quiz attempt viewed. Next, we have description, which is the narrative description of the action performed by the user, like the user with ID 1603 has viewed the attempt with ID 2022 belonging to the user with ID 1603 for the quiz with course module ID 1884. Then we have the origin, which is the method used to access Moodle, like web or client, etc. Last but not the least, we have IP address, wherein if Moodle is accessed via the web, this gives the originating IP address, which was anonymized or deleted to ensure data privacy concerns. Then we measure the transaction log volume or count as the indicator of participation. A transaction is defined as any interaction with Moodle. Like for instance, if a student submitted an assignment, that is one transaction. If a student submitted a quiz, that is one transaction. If a student is viewing a notification on the course, that is also a transaction. And we did not consider the actual content of the transactions. Before proceeding to explaining causal impact, it is important to know what is causal inference. Causal inference refers to a family of analysis methods that enable researchers to draw conclusions about the effect of a causal variable or treatment on some outcome or phenomenon of interest. This involves having to compare the difference between two time periods, before and after the intervention, which is difficult for time series data since they are not independent samples over time. Fortunately, there have been attempts to create models for applying causal inference to time series data. Examples include interrupted time series or ITS model, which uses a segmented regression model with dummy variable representing the period of the intervention for evaluating the effectiveness of population-level intervention. It is simple in terms of interpreting the results. Next, we also have the Prophet, which was developed by Facebook. It's a type of generalized additive model consisting of trend, seasonality, and holidays. There's no need to interpolate missing value since the model handles time series analysis as a curve-fitting problem and can predict future values at a very high accuracy. Last but not the least, of course, is causal impact, which is an R library developed by Google to evaluate the impact of a market intervention using difference in difference to infer the causality from observational data. Under the hood, it builds a Bayesian structural time series model based on multiple comparable control groups or markets and uses the model to project or forecast a series of the baseline value for the time period after the event. We have found out that ITS had weak predictive power and limited flexibility, while Prophet was better than ITS at predicting future values. In determining the impact of an event, though, Prophet was more difficult to interpret, which is why we have decided to use causal impact for this study, which is a specific type of causal inference that enables researchers to estimate the impact of an intervention, such as an ad campaign, on an outcome variable such as additional clicks. Given time series data, we first identify predictor variables, the outcome variable, and the pre- and post-intervention time segments. Causal impact then uses the pre-intervention data to model the relationship between the predictor variable and the outcome variable. It then uses the model to estimate the post-intervention counterfactual. The impact of the intervention is the difference between the counterfactual and the observed post-intervention data. There have been many use cases for causal impact, specifically marketing data and clickstream traffic, which causal impact is originally designed for. However, more recently, causal impact has been used in other use cases like modeling the effects of product modularity on bus manufacturing, US cyber policies on cyber attacks, Arab uprisings and tourism, performance of App Store releases, and even estimating the effects of COVID-19 school closure on student use of the LMS Moodle and the electronic book reader book roll in a paper by Cormier et al. In fact, the paper that we have made, which serves as the basis for this presentation today, is actually inspired by the Cormier paper, which concluded that as a result of COVID-19 school closure, the student use of the LMS Moodle and the electronic book reader book roll significantly increased. Proceeding now to data preprocessing, the raw data consisted of 3 files of user IDs and user type, each file representing a user type, and 1 transaction log file for each of the 123 days of the academic term under study. We first merged the list of user IDs and user type with the transaction logs. We eliminated identifying features such as IP addresses, user full name, and ID numbers. We also had to pause and separate the time column into separate date and time features. The log file was then aggregated according to the date, user type, and component, and the rows that fall under each category were counted. All preprocessed files were then appended to a single file of transactions. The second phase of the data preprocessing procedure, just prior to the causal impact analysis, was to normalize the data. We first aggregated the data frame according to user type and component columns. We took the maximum possible total for each group across all dates. Then the items in the total column were divided by their respective maximum possible value according to the user type and component, normalizing the data between 0 and 1 for each user type and component. For some example, here's a sample of the collapsed data. As you can see in this table, the user type and component pair shown here is non-editing teachers and all logs. October 10, 2020, for that particular date, we have a total of 305 logs, while for December 23, 2020, we have a total of 1,133 logs. And what we did for the normalization procedure is that for this particular user type and component pair, the non-editing teachers and all logs, the maximum possible number of logs across all dates is 6,146. Therefore, that maximum number, we're going to use that for the normalization. For instance, for the date October 10, 2020, it has a total of 305 logs. Then we divide it by the max, which is 6,146, to give the normalized data of or value of 0.05. While for December 23, 2020, with a total of 1,133 logs, we divide it by the max of 6,146 to give the normalized value of 0.18. We then analyze the following components: overall logs, system, which refers to all transactions related to course communications and management, such as course viewed, course search, dashboard viewed, message sent, and user has logged in. Also, we also analyze assignment, which is all transactions related to editing, viewing, completion, and grading of assignments, like a submission has been submitted, feedback viewed, and submission viewed. And last, we also analyze the quiz, which refers to all transactions related to quiz attempts, submissions, creation, and grading. Examples include quiz manually abandoned, quiz attempt started, and quiz attempt viewed. Take note though that system, assignment, and quiz, all of the logs pertaining to them comprise more than 88% of all the Moodle logs that we have analyzed. For the input variable, we selected student data as our outcome variable, just like the Cormier paper. But unlike the Cormier paper, we have decided to use teacher and non-editing teacher data as our predictor variable. This has something to do with the teacher expectancy effect, which asserts that teacher expectations have an impact on students' academic progress. And it has been observed at the individual and class level for both achievement outcome and self-concept, and have been shown to persist over time. We also use dynamic time warping, or DTW, to arrive at the parsimonious set of predictor variable. We eliminated the features with no predictive power, leaving only those that could give us a reasonable estimate of student behavior. The usual approach to finding the relationship between a predictor and a response variable in time series data is to use the Euclidean distance. However, this penalizes instances where the relationship between data have shifted. Dynamic time warping therefore finds the distance along the warping curve as opposed to the raw data to arrive at the best alignment between the two time series. And we have used the market matching implementation of the dynamic time warping algorithm, which is available as well as an R package. Take note, however, that the market matching implementation requires that the values in the predictor variable should be complete and that the variance or the standard deviation should not be equal to 0. Therefore, to guarantee this, we have decided to use that only top 10 most frequently used components across all user types rather. And here are the resulting outcome and predictor variable. Firstly, for the all log, the predictor variables include non-editing teacher system, teacher file, teacher open forum, teacher system, and teacher URL. While for system, we have non-editing teacher file, non-editing teacher system, non-editing teacher URL, teacher file, and teacher system. For the quiz, we have non-editing teacher file, non-editing teacher quiz, teacher assignment, teacher file, and teacher quiz. And lastly, we have assignment. We have non-editing teacher assignment, non-editing teacher system, teacher open forum, teacher system, and teacher URL. Lastly, let's discuss the time periods that we have inputted in causal impact. For the pre-intervention period, we have September 9 to October 28, which was the period before the typhoons. And then for the intervention period, we have October 29 to November 13, the period during which the two typhoons struck. And last but not the least, post-intervention period, which is November 14 to December 23, the period after the typhoons left. Now going to the results. Firstly, for all LMS activity, it decreased significantly after the typhoon with P equals 0.01. The response variable had an average value of 0.8 in contrast to the counterfactual prediction of 0.23. The typhoons therefore had an estimated effect of negative 0.045 with a 95% interval of negative 0.082 and negative 0.010. When the data points during the intervention period are summed, the response variable had an overall value of 7.41, and the counterfactual prediction was 9.25 with a 95% confidence interval of 7.83 and 10.77. What you're seeing right now is the causal impact graph for all LMS activity. Let me explain the graphs one at a time. At the topmost graph is the original graph. And as you can see, the black line graph right over here at the original, this pertains to the observed data. Whereas the dash blue line graph right over here pertains to the predicted data, while the light blue band that you're seeing right here is the confidence interval of the prediction. Moving on now to the point-wise graph here at the middle, you can see that the line graph here depicts the difference between the predicted and actual data. And last but not the least, at the bottommost graph is the cumulative graph, which shows the line graph depicting the accumulated difference between the predicted and the actual values over time. As you could observe as well in the point-wise and cumulative graph, there's a gap right over here. That is the intervention period. And as you can see also in the cumulative data, the differences between the actual and the predicted values are accumulated post-intervention. There's no accumulation whatsoever in the pre-intervention period. As evident in this graph, in this chart rather, or graph, the LMS activity has significantly decreased after the typhoons. Moving on to system, it also decreased significantly after the typhoons with p-value equals 0.01. The response variable averaged 0.11 as opposed to a counterfactual prediction of 0.15 with a 95% interval of 0.12 and 0.19. The effect of the typhoon is estimated at negative 0.046 with a 95% interval of negative 0.080 and negative 0.013. The sum of the response variable data points during the post-intervention period was 4.43 in contrast to a predicted 6.30 with a 95% interval of 4.96 and 7.71. And here's the causal impact graph for system. And just like the all LMS activity, it also significantly decreased after the typhoons. Next, assignments. It is not statistically significant. Even though it has a p-value of 0.04, the student participation sign fluctuated. It showed a decrease of negative 18% with a 95% interval of negative 37% and positive 2%. The fluctuation of the sign meant that the result cannot be meaningfully interpreted. Lastly, we also have Z, which is also not statistically significant because it has a p-value of 0.39. This implies that students continue to comply with assignments and quizzes as they make measurable contributions to the grades, while system behavior such as checking the course for notifications is generally not graded. This study, however, has some limitations, including the following. Firstly, causal impact analysis requires that the predictor variable should not be affected by the same intervention as the response variable. Teachers and non-editing teachers were very likely affected by typhoon, just as their students were. We have provided these counter-arguments to that limitation. Firstly, we use dynamic time warping to find the teacher and non-editing teacher feature that were most predictive of student behavior. And we go back as well to the theoretical framework regarding the teacher expectancy effects as mentioned earlier in the presentation. Another limitation is the population sample, because the students in the sample were among the best in the country. They generally came from well-to-do socioeconomic background. Hence, the resilience is not indicative of the resilience of the Philippines or any developing country as a whole. Next, we also have the choice of the learning management system and course of students. The university had two LMS working in parallel, Moodle and Canvas. Classes using the Moodle server were generally the computer science and management information systems classes. The students were therefore technology savvy and adept at online modes of communication. Students from other courses might have encountered greater challenges. There are also other factors as well. The study does not capture the following additional factors such as assessment results, the quality of the educational experience, and the mental health consequences of COVID-19 coupled by severe weather. Therefore, it is best to triangulate these results with findings and observations from other constituency checks for a more complete reading of our community. With that said, here are the contributions of that particular paper. Firstly, by applying causal impact analysis on LMS data from the Philippines to determine the effects of severe weather on students. It also contributes to what is quantitatively known about how Philippine students cope with online learning. In the context of COVID-19, very specifically, this kind of study is very scarce. In fact, when we did a survey of the related literature on only the paper by Mia and also the paper that Ma'am did and I submitted to and presented at AIED 2021 were the only one involving the use of causal impact on learning management system. With that said, it is time to extend the study, or more specifically, extending the time period. So far, what we have focused on is the second row right in this chart, called intervention, no break, post-intervention, no Christmas, or NB and C right over here. Now we are going to add 3 more time periods. Firstly, we have intervention, no break, post-intervention with Christmas or NBWC, wherein the pre-intervention is September 9 to October 28. Intervention is from October 29 to November 13, and the post-intervention is from November 14 to January 9. And then we have the intervention with break, post-intervention with Christmas or WBWC. And just like the previous time periods, the pre-intervention period is from September 9 to October 28. The intervention is from October 29 to November 21. And the post-intervention is from November 22 to January 9. Lastly, we have the intervention with break, post-intervention no Christmas, or WBNC, wherein the pre-intervention is from September 9 to October 28. The intervention is from October 29 to November 21, and the post-intervention is from November 22 to December 23. With that in mind, the new findings is that for all LMS activity, NBWC decreased significantly with P equals 0.02, while as mentioned earlier, NBNC also decreased significantly with P equals 0.01, and WBWC, however, is not significant, although P value equals to 0.044, the sign fluctuated, while for WBNC, it's also not significant because while P equals 0.033, the sign also fluctuated. This is the causal impact graph for all LMS activity with the extended time periods. For the system, NBWC is not significant, although P equals 0.03, the sign fluctuated. As mentioned earlier, NB&C also decreased significantly with P equals 0.01, while for WBWC, it is not significant, although P equals 0.04, the sign fluctuated, and WBNC, it decreased significantly with P equals 0.01. And this is the causal impact graph for a system for extended time periods. For the assignment, for all time periods, it is not significant. And the same thing could be said for quizzes. All time periods, not significant. Therefore, what can we conclude about this? Since time periods WB, WC, and WBNC included the class suspension, it is possible that the definition of the intervention period was too long and that the effect of the typhoons had already worn off. The class suspension was enough time for students to recover from the typhoons and for online participation to return to pre-typhoon levels. This study may provide some hope, i.e., it is possible for students to be resilient and indeed overcome adverse environmental conditions and continue to thrive in their education. Or it may be the case that prior work focused on the effects of extreme weather on underprivileged students, whereas the students in the study sample came from middle to upper socioeconomic background. Hence, the effects on the study sample were not as severe nor as long-lasting as they would have been on students from families with lower income level. And as the AIED 2021 paper mentions regarding this, it may serve at least as an upper bound. Now, with that said, here are the main takeaways. Firstly, causal impact can be used to measure the impact of an intervention on an outcome variable. And it is very simple to use. We just need to supply the outcome variables, the predictor variables, and the pre- and post-intervention period. While all Moodle LMS activity significantly decreased in the short term, it no longer became statistically significant in the long term, which may be indicative of resilient recovery from typhoons. Assignments and quizzes were also not statistically significant for any of the time periods presented. This could mean that students still place effort in completing the requirement despite the challenges. Lastly, further studies need to be done which takes into consideration the limitations of the study, most especially socioeconomic background, as stated a lot of times in this presentation. And with that said, here are the references that we use for the presentation and the papers. And this officially ends my presentation. Thank you very much for listening. And I now open the floor for your questions.
Okay, thank you so much, Kiel. Thank you for the presentation. And I apologize again for the technical errors. Maybe for the benefit of the people who weren't able to attend, could you talk a little about the the data preparation. I know you covered it a little bit in the presentation itself, but how did you go about preparing the data or summarizing the data to make it
Okay, let me go
to get
back
it
to the
critical?
slide on that one though. Okay, once again, for the data preprocessing, the raw data consisted of 3 files of user IDs and user types, when each file represents a user type, and one transaction log file for each of the 123 days of the academic term on the study. We first merged the list of user ID and user types with the transaction log. We eliminated identifying features such as IP address, user full names, and ID numbers. We also had to parse and separate the time column into the separate date and time features. The log file was then aggregated according to the date, user type, and component, and the rows that fall under each category were counted. All preprocessed files were then appended to a single file of transaction. In other words, let's say for each date, user type, and component combination, we count all the rows that fall under each combination, and then the preprocessed file were then appended to a single file of transactions. Then the second phase of the data preprocessing procedure, just prior to the causal impact analysis, was to normalize the data. We first aggregated the data frame according to the user type and component columns, and we took the maximum possible total for each group across all dates. Then the items in the total column were divided by their respective maximum possible value according to the user type and component, normalizing the data between 0 and 1 for each user type and component. So as you can see right here, let me give a rundown again, an example of the collapsed data. Here it is the user type component pair, non-editing teachers, and all logs. For instance, for October 10, 2020, the total number of logs is 305. And for December 23, 2020, that is 1,133 logs. Across all the dates, the maximum possible number of logs for non-editing teachers and all logs is 6,146. Therefore, we use that for the normalization procedure. For October 10, 2020, 305 divided by 6,146 gives you 0.05. While for December 23, 2020, it's 1,133 divided by 6,146 to give 0.18 normalized value. And that is all to explain how the data preprocessing works once again.
Okay, thank you, Kiel. All right. And could you say a little about steps moving forward? What are our next steps in the analysis of this data set?
Okay, based from the limitations, the next step in the analysis of the data set is currently we're still revising the RPTEL draft on the use of the extended time periods as mentioned earlier for the causal impact analysis, and we are also planning to do causal impact analysis as well on Canvas data as well. But specifically, we would like to use causal impact on Canvas data from second semester of academic year 2021 to 2022 because during that time, and as you have heard, the Ateneo Loyola schools are already transitioning to partial face-to-face classes, and we would like to see how what its impact is on the Canvas login time. And although we still have to figure out the research question for that one though, and that's all I could say though.
Okay. Kel, could you say a little about the other work that you're doing that's not necessarily related to this, but the work that you're currently preparing for publication?
Okay, aside from causal impact, I'm currently also doing social network analysis on Canvas data discussion forums. And more recently, we are able to submit an extended abstract pending review to AIED 2022, which is a preliminary study on the use of Canvas data discussion forums for analysis. And what the paper is essentially we essentially analyze the grading schemes of the professors using the discussion forums, and also the frequency of the user type to user type sender recipient occurrences, like let's say the number of student to student posts or student to teacher posts and something like that. And then also for ICCE 2022, we are applying on the SNA proper based from another publication, and that is all I could say.
All right. Thank you, Kel. Maybe to wrap things up, could I ask you to maybe give, like for the people who are listening who are interested in doing this kind of research, can you offer some sort of general advice or encouragement, maybe in terms of how they can prepare their or sorry, maybe in terms of what types of open questions they can pursue or what kinds of skills they should try to develop in order to become good data scientists who want to study this kind of data? Like, what advice would you give them?
Okay, first, yeah, I have lots of advice to them. Firstly, you'll have to be able to read a lot of related literature, and that way you'll know if you're going in the right direction when it comes to analyzing the learning management system. There are lots of good papers though. You can search them on Google Scholar, or if ever I have there's a paper that Mom Did It always recommend. Is that right, Mom Did It?
Which one?
The paper, right? Let me check first for that paper though. I think I have it. Just wait.
Sure.
Okay. Here. There's one paper that Mom Did It highly recommends. It's entitled "Educational Data Mining: A Review of the State of the Art" by Cristobal Romero, and also there is another Romero et al. Paper entitled "Data Mining in Course Management System: Model Case Study and Tutorial." This is for Mom Did It really highly recommends it, most especially for LMS research beginners. Is that right, Mom Did It?
Yeah, I think that's a good choice.
Okay, and also, secondly, aside from reading lots of related literature, you should also be careful about data privacy, because in LMS research, you'll be dealing with data that contains like emails or names of persons or cell phone numbers and even URLs as well. And we when we collected the Moodle and Canvas data, we are very careful to anonymize the data. And during my early days as an LMS research assistant, I was able to help out Sir Miguel Zenon in anonymizing the Canvas data as they are collected via the AWS via AWS. And also another advice, make sure you really have a good mentor. Like, of course, me, I have Mom Did It as my mentor for the LMS research, and by that you will be able to know if you're going in the right direction. And last but not the least, and most importantly, always pray. Always pray to God for wisdom, and who knows, God will give you some ideas, and God will spark your imagination and creativity, and no find out what you really want to survey with the or and analyze with the data. And I think that particularly happened to me, most especially with the what I'm doing right now regarding the applying social network analysis on Canvas data.
All right. Well, thank you so much. Thank you so much, Kiel, for your time and for sharing your expertise. And once again, you continue to be an inspiration, I think, for people who want to get into this field. You've done a lot of really good work, and I think you're just getting started. I think there's even more in your future. So thank you so much for your.
I do have one more advice though. It has
go
something to
ahead.
do with the nature of the data though, because when you're dealing with LMS data, you're dealing with big data, and it's really really big. Moodle data and Canvas data, you're going to get very big log files, and so I suggest that you also research as well on multiprocessing to so as to help make the process faster. And I also do I also do have a GitHub repository for a program that can help me process the Canvas and Moodle data across multiple computers. And don't worry, I'll be sending in the link alongside the recording of this video.
All right. Thank you so much, Kiel. And I think we can wrap it up from here. Thank you. And I'll see you again soon. Bye, everyone.
Right. Thank you very much, Ma'am Didit.
Okay. Bye-bye.
Bye, everyone.